As you know now that if we want a continuous flow of current in a circuit, we need to maintain a potential difference. So that means for continuous generation of current there should be a potential difference, and due to this only we introduce a battery or a cell into a circuit. We already discussed in the previous lecture, and that battery or a cell contain two terminals, and those terminals will always have a potential difference. They won't have the same charge in them. So out of them, one is going to always be at high potential and the other is going to be at low potential. So that means for the continuous generation of current there has to be a potential difference. So this thing actually led to the formulation of Ohm's law by scientist Ohm. He said that at constant temperature, current flowing through a circuit is directly proportional to potential difference applied. Again, I am just going to repeat this definition for you. It says that let the temperature remain constant. So let us say that temperature is constant. So at constant temperature, the current flowing through a circuit, that is the I, is directly proportional, that means it varies directly with potential difference applied. Or we can say that V is directly proportional to I. We can write in either form. So removing proportionality sign, as we all know, in order to convert the relation into a formula, we need to use an equal to sign, and to put that we need to remove this proportionality sign by putting a constant. So here we put a constant R. R is constant. Now sometimes the constant has some name, and sometimes it is only called as constant of proportionality or proportionality constant. But in this case it has a specific name, and its name is actually resistance. Its name is actually resistance, and this resistance actually has a meaning. Now we are going to discuss about that, but before we discuss, I am just going to plot a graph showing that V is directly proportional to I. So let us say that let us plot a graph, V on this axis, I on this axis. So as it was proved that it is directly proportional, it varies directly. That means if this get increased, this also get increased by the same amount. If this get decreased, this also get decreased by the same amount. So if we talk about the graph, so graph is a straight line. And what does this line actually denotes? This denotes the resistance, that is the R. It denotes the resistance. So this is the graph for the Ohm's law. Now in order to know about resistance, that what actually is the resistance, what happened actually, see, suppose I have this wire, so we have electrons in it, we all know that there are electrons, and electrons are actually moving. So when the electrons move, they collide with each other. When the electrons move, they collide with each other. It's just like many cars moving on a road. So what happened when many cars are moving on a road, then what happened, they collide there is a chance that they collide among themselves. And also if I say that the road has a boundary around it, so there is a chance that the roads may collide with the boundary wall also. So likewise here also the electrons can collide among themselves, and like this, and also with the wall of the wire, inner wall of the wire. So what is going to happen, like I told you that there can be a collision, there can be accident between two cars. So if there will be, when the two cars will collide, what is going to happen, it will create a jam. That means the cars which are behind will not be able to move. So that means the hindrance is offered to those cars. So likewise in this case, when the electrons collide with each other or the inner wall of the wire, so what happened, the electron present behind, like this if I am talking about, see if these two electrons collide, so this electron path is just hindered. This collision is actually offering an obstruction to that path. This measure of obstruction is called as resistance. So what is resistance? Resistance is the obstruction. Resistance is the obstruction in the flow of charge or electron through wire. It is the obstruction in the flow of charge through wire. Now what is the reason behind? I told you the reason is they may collide with each other, or they may collide with, electron may collide with inner wall of conductor, inner wall of conductor. So these two may be the reasons in that case. So either this happens or this happens, that means there is a hindrance offered to the path of the electron. So this is what is called as resistance. Now if we need to know the factors on which resistance depend, we can derive from this only. As we know that V is equal to IR. So we can have the formula for the resistance, it is V upon I. It is V upon I. And if we talk about the unit, because the constant may or may not have unit, it depends. But in this case resistance have the unit, and resistance have the unit, and what is the unit actually? The unit for the resistance is ohm. The unit for the resistance is ohm. The scientist Ohm actually introduced the term this resistance. So he kept the name of the unit after its name, that is the ohm. And how we denote ohm? We denote it by like this. We denote it by this. So 1 ohm is equal to, potential difference is measured in volt. So it is 1 ohm is equal to 1 volt over 1 ampere. As we know, the unit for the potential difference is volt and unit for the current is ampere. So this is how you are going to relate 1 ohm, that is 1 ohm is equal to 1 volt over 1 ampere. Now if in case you need to define that, then how you are going to do that? Again, no need to cram that, you can actually make a definition yourself. You write that resistance is said to be 1 ohm when 1 volt of potential difference is applied, when 1 volt of potential difference is applied, which allows, or you can say which permits, 1 ampere current to flow through wire. So I am repeating again, resistance is said to be 1 ohm when 1 volt of potential difference is applied, which allows 1 ampere of current to flow through wire. So this is what is the how you are going to define the the unit, SI unit for the resistance, that is the ohm. So this is what you can say that how we are going to how it is being explained as Ohm's law, or what is the graph and what is the resistance. And moreover, you know that there are certain factors on which resistance depends. So we are just going to focus on the factors on which the resistance depends. So I think you got it, that what is resistance actually? It is just the hindrance in the path of the flow of the charge. And you know that every appellants I am talking about has certain resistance. May range from low to high, but it is always going to have certain kind of resistance. There is no appellants which has all, means we can say that we have conductors which have nil resistance, but still there is minute resistance present in every appellants. Now we are just going to look that on what factors the resistance depend. So we see that resistance depends upon length of the wire. Resistance depend upon length of the wire. It depends upon area of wire. It depends area of cross section. I'll write here. It is area of cross section of wire. It depends upon length of wire, it depends upon area of wire, it depends upon the material of the wire, that from which it is made, and it also depends upon the temperature. It also depends upon the temperature. So these are the 4 factors on which the resistance depend, that is it depends upon length of the wire. Now first we are going to see that how it depends upon length. So it is proved that resistance is directly proportional to length. That means more is the length, more is the resistance, or less is the length, less is the resistance. I am going to prove it with example. Suppose you have a wire of this much length and you have a wire of this much length, or let us consider them as roads. Let's say that here my car is going to cover this much distance and here my car is going to cover this much distance. So, in like if we take both of them, in which you are having a more probability of collisions, where will be the more collisions, in this short distance or in the long route? Obviously in long route. Suppose we are driving a car on a busy road, there are too many cars which are just moving along, so that means the chance of collisions will be more on the road which is more long, because longer the distance, more is the chance of, more it is prone to accidents, you can say. So in the same manner, if the electrons are moving from here to here in this wire and the electrons are moving from here to here in this wire, obviously the chance of collisions are more in the wire with the which is longer. So that means more is the length, more is the resistance, less is the length, less is the resistance. Secondly, what is there? It is, if we depend upon area, let's say we have a thick wire and in another case we have a thin wire. In one side we have a thick wire, in another side we have a thin wire, or we'll just relate with the roads again. Suppose I have a wide road on which the traffic is moving and we have a narrow road where the traffic is moving. So in which of the two you see that more number of collisions are going to happen? Obviously the chances of collisions will be more on the narrow one, because the road is narrow. So that means there are you can say many chances that the cars may collide into, or you can say bang into each other. So in the same way, if the electrons are moving, they can move more smoothly in this case as compared to this, because the chances of collisions are more in this wire, that is the narrow one. So we say that resistance is inversely proportional to area. More is the area, as we have seen, less is the resistance, less is the area, more is the resistance. So combining both, first we will derive a relation by combining both. So combining both, we have R is directly proportional to length over and inversely proportional to area. Removing proportionality sign, we always put constant. So here also we put constant, and that constant is rho. That constant is rho. Alright, rho is actually the name for the symbol. Rho is actually the name for the symbol. Otherwise, what is this quantity? This is specific resistance. This quantity is specific resistance, or we can also call it as resistivity. We can also call it as resistivity. So it can be called as resistivity or specific resistance, but it is denoted by a symbol, that is the rho. So R is equal to rho L upon A is the relation. Now we will define this quantity as well, but let us focus first on these two factors which are left. So third factor which we were discussing, that the resistance depends upon the material of wire. We have different materials of wire. One is conductor, semiconductor, insulator. We have already discussed conductor is one which has almost nil resistance, semiconductor which has moderate resistance, and insulator which has maximum resistance. So this also depends that what kind of material the wire is made of, because depending upon that we will have the resistance. Fourth is the factor, that is the temperature. We know that suppose here I am going to compare temperature with an acceleration. Suppose you have a car, I am driving a car, and what I am doing is I am just accelerating a car. So I am just putting my feet on the the one which is present below, that is you have clutch, brake and speed one. So accelerator, what we call as. Suppose I just put my feet or press my feet on the accelerator, or I just accelerate a car. So that means the car will start moving more faster, and as the car will start moving more faster, so there is a chance that it may undergo many collisions. So likewise here also, if you increase the temperature, then the electron will gain some energy and they will start moving more with more energy, more kinetic energy, and more they will move, there is more chance, more will be the speed, and obviously they are going to bang into each other. More collisions, that means more hindrance, that means more resistance. So we say that resistance is directly proportional to temperature. In most of the cases it is there, but in alloys it is different, we will discuss later. But otherwise, if you talk about the temperature, with increase in temperature, the energy of the electrons increase, speed increase, the collisions increase, and therefore the hindrance increase, that is the resistance increase. So these are the factors. Now let us take up this rho first. So if somebody asks you about specific resistivity, then what you are going to say is specific resistivity is denoted by rho. And if you are asked for the formula, then we are going to derive this formula from this relation. So we have rho is equal to, just putting this here and just shuffling them, R into A upon L. So this is the formula for the specific resistivity or the specific resistance. Now let us see the units. So we know that unit for the resistance is ohm, and area is meter square, length is meter, meter cancel out. So that means unit for the rho is ohm meter. SI unit for the resistivity is ohm meter, and if we can also have a smaller unit, that is the ohm centimeter, but otherwise it is the ohm meter. So this is how you are going to derive the formula for the resistivity. Now if somebody asks you to define it, then we can also define it. How? Let us say R is equal to rho L upon A, or rho is equal to R into A upon L. Let us assume that length of wire is 1 meter and area is 1 meter square. This is just an assumption. When you need to define rho, then only take these things as unity, otherwise you will be given that what you need to take. So I am just going to define it. So therefore I am taking the length of the wire as 1 meter and area 1 meter square. Putting values here, we have rho is equal to R, because this also become 1 and this also become 1. So how you are going to define rho? We say that specific resistance, this one, is numerically equal to, because the value is going to become equal, numerically equal to resistance of wire of length 1 meter and area 1 meter square. So that means specific resistance is numerically equal to the resistance of wire of length 1 meter and area 1 meter square. You know that like practically it is a technical term, that resistance is the obstruction to the flow of charge and specific resistance is the this one, numerically equal to the resistance of wire of length 1 meter or area 1 meter square. Or if we talk in a general sense, then what is the difference between resistance and the resistivity? See, resistivity, resistance first I am talking about. Resistance is the total obstruction offered by the conductor. It is the total obstruction which is offered by the conductor. But if we talk about resistivity, it is the resistance of 1 meter square area and 1 meter. So this gives us the resistance of the length 1 meter and area 1 meter square. So that means it is again a measure of resistance, but a measure of resistance of a specific part, and that part is 1 meter length and 1 meter square area. But if we talk about the total one, that is the resistance. So this is how you are going to define this resistance, specific resistivity, and don't forget that specific resistivity and resistivity is one and the same thing, even specific resistance. And moreover, see that this thing, the resistivity, like different, like if I say that wire is made up of copper, or wire is made up of nichrome, or wire is made up of tungsten, so all those wires are going to have the different resistivity. They are just going to have the different resistivity. So, and for a same wire we can say resistivity remains same. Suppose I say I have a nichrome wire and I am just going to half it, then what happened? What happened to the resistivity? It is going to remain same, because the resistivity is just the measure of the resistance of length 1 meter and area 1 meter square. Let us now try to put the resistance. So just look at the board carefully.